Hello, everyone. Thanks for joining this session on Mulesoft API design. Before we get started, a little bit about myself. I'm Pawan Kumar Ogireddy. I'm a certified Mulesoft integration architect. I'm based out of Houston, Texas. So today we'll be covering API design, some of its best practices. So this will set a foundation for the demo that I'll be going over for MuleSoft Design Center. I'll be focusing on RAML and OAS, which are the popular API specification languages that are available. API design, right? Before we even talk about design, I wanted to emphasize on how important APIs are in the modern world. So we have all these different systems and applications that are evolving in the organizations, and also the industry 4.0 technologies like artificial intelligence, machine learning, blockchain, IoT devices, right? So and 5G is also another uh, technology which is coming over. So a lot of changes are being done in the IT landscape. So it is very important for us to have the building blocks uh, in our organizations, which are APIs. So when we talk about APIs, consider them to be assets, right? Like companies have financial assets like cash, stocks, different financial instruments. Now organizations are actually thinking about APIs as assets. So they want to use or leverage these APIs that they build today so that they can scale up or innovate in the changes that would be coming in the future. So when we talk about API design itself, right? Uh, let's talk about the traditional design that we have been doing in the IT world. In a SDLC process, a design would consist of uh, different prototypes, high-level designs, and then followed by a low-level design, typically done by a developer, right? And then once that is done, an application is built. But if you noticed one thing, there's no customer feedback here, and as the application is built, a demo is given to a customer, and then they give a feedback, and then there's a lot of rework that has to be done because we have spent so much time in building the application itself. Same goes with modern applications as well. You can get the design done rapidly, develop something in an agile fashion, and get customer feedback. But then it is still not as intuitive uh, because customer can see the design, review it, but then uh, the design itself doesn't translate back into the build most of the time. So with MuleSoft and the RAML and OS technologies, we can actually use these API specifications to get the customer feedback right away. So I'll be going over this more in the demo. And the other point that I want to mention is the design itself can be used to build, right? So in the initial statement that I mentioned, that design and development are not linked together. There can be miscommunication, or there may be a difference in comprehension of how the original document or the design was written. So MuleSoft eliminates these things by using this design to actually build your artifacts. So your design is basically linked to the the flows or the development that you would do for these APIs. So an important consideration for API design is the protocol that you would like to use. You may choose to develop your APIs in HTTP or SOAP. So based on these protocols, you may have to use certain rules or their nomenclature to adhere to that protocol and design your apps, right? In this session, I'll be primarily focusing on HTTP, which is widely used for REST APIs. So here I'll be talking about design considerations. I cannot emphasize enough that for any API that you would develop, the developer is of the prime focus, right? So the API that you would be building should be usable and easy to use. So this is basically there are two ways in which you can think about design here, right? One is the consumption model, which is a top-down approach where you have the customer in mind and design APIs for them. And then you have an exposure model wherein you have data available in your organization and you want to expose the data and then eventually uh, meet the needs of your customer, which is the developer here. So some of the key characteristics of a good API, right? First is usability. So the endpoint or the contract that you would have and the statuses, error responses that you would get from an API should be very intuitive and easy to use. So just by looking at the documentation itself, a developer should be able to understand what the API does and then what are the options available for them to pull data. Second is understandability. So again, this is pretty much relevant to the first point wherein uh, an API can be documented in a certain way, but then the developer may still end up misusing the API because of comprehension issues and there's no proper feedback or guidance. Third is consistency. So all APIs should follow the same standards. So as the API network evolves, there will be a lot of challenges with the consistency because you'll have more developers onboarded and then they may have different experiences, different standards that they may adhere to. So coming up with a common standard and adhering to that would be ideal. Obviously, these things don't happen on day one, but as organizations evolve, they eventually get to that state. So here I'll be talking about API design best practices. So in general, when we design an API, right, we have to think in terms of how we can come up with an address. So that's the analogy that I want to give you before you can actually get to the design itself. So when you want to send a letter, right, you have your address. For instance, I have a dummy address here. So so you want to send your uh, letter to uh, 5321 Sunset Drive to an apartment, and then the location, the city is Houston, state is Texas, and then you have your zip code. So there's a contract here, right? So each of these fields in the order mean something for the postal system to understand this and deliver your mail to the right person on the other hand. So when you design an API, always think about this example wherein when you come up with an endpoint or the query parameters or the URI parameters, that are you actually making this intuitive for the user? So to make any API intuitive, the first thing which is very important is the naming standards or the terms that you would use to actually get to the right endpoint name. So it is best practice to use general business concepts when you design your APIs. So for instance, your company is working in insurance industry, finance, or retail. So you would have a particular nomenclature that you would use in those industries, and you should try to use that generic business terms. And at the same time, you should avoid using the company internal terminology. For example, here, the in the industry, the insurance industry, right? You have agents, right? But some companies may choose to call them brokers or channels. Uh, the second example I have here is exams, right? So exams is a very general business term in the education domain, but then you can have Pearson or some other company which may be using specific terms like GRE and GMAT, because that's how they know that these know about these tests, or that's how they understand these tests, and that's their common language. So the bottom line is avoid using the common language which is used in your company, and then try to use the business terms which are domain specific. Try to use nouns as much as possible, because I'll be going over this concept in the next few slides, but then there's a concept called resources and collection. So resource is uh, a unit of a record wherein you, for instance, employee would be uh, a resource, and a collection would be employees, which is a list of employees. So it is easier to pluralize a noun. So it's a best practice to use a noun here. So when we talk about endpoints, right, we always think about the request, but then your response should be very intuitive as well. For instance, you write a SQL query, right? Uh, you write a wrong query, then you get an error response. You write the right query, like you update the records for, let's say, ID 123, then you get a proper feedback that you know one row was updated and stuff like that. So you want that kind of a feedback, or even a better kind of feedback from an API, because this will be used across the organization and outside by your business partners. So the next is sample responses. I think I've emphasized this enough that we always need feedback from your customers, and sample responses definitely help you get that feedback right at the design level. So now that we talked about API design, I'll focus on the RESTful design now. I think this is the most popular technology right now. So REST means representational state transfer. That's the short form. So it basically consists of a base URL and an endpoint. So base URL can be something like www.mulesoft.com, which would be the domain name. And the endpoint can be products. So endpoint would consist of your URI parameters, your endpoint, and the query parameters. So I'll be going over those in the next few slides. So each URL is a representation of an object here. So when you have an endpoint, it determines an object or a collection of objects. So we have HTTP verbs, which basically denote the DB CRUD operation. So I'll just give you a comparison between both of them so that you can grasp this concept better. So in database, we have CRUD operations. Uh, C means for create, R means for read, U for update, and D for delete. So HTTP also has similar methods. uh, which can be applied on these endpoints. So here post is equivalent to create. So for instance, you have an employees endpoint. So it will allow you to create an endpoint or bulk insert a list of employees. Uh, and in the extreme right, I have employees slash 123. So 123 is the employee ID here. As this is a post, if I can't create an employee ID because it doesn't exist here. So that's why this is an invalid request. Next, I have get request. So get is similar to read here, the R in CRUD. And then you can get all the list of employees with this endpoint. And if you use this method on the same endpoint, you will get the details of employee 123. So the next one is put, and put is the U of the update from the CRUD, right? So you'll be able to update the employees with a matched filter criteria. Similarly, if it's done on a particular employee ID, if it exists, then it will go ahead and update that. Similarly, we have delete here, and then once it can delete all the employees, or you can basically delete a single employee. So here, if you look at the endpoint itself, it's pretty intuitive. You have employees, and then the next item would be the employee ID. So once you have the employee ID in your endpoint, you know that you're only interested or you're only acting on that employee ID. Also, another observation here, if you notice that you have the endpoints same here uh, for each of these different methods that you have. So it is as if you are writing a SQL query across these uh, intuitive endpoints and getting the results out of it. So a little bit more about endpoint, right? So endpoint also consists of URI parameters. For instance, in the previous slide, we have 123, which is the employee ID, and that's nothing but the URI parameter. Uh, so when we talk about endpoint, we also have to talk about resource hierarchy. Uh, so let's consider this example where you have employees, departments, IT, and employee. So you see this hierarchy here where you know that there is a department in the company, and then you want to get drill down a bit further into the IT department, and then you want to know what the employees are. So you often use this hierarchy from left to right. So each of these different sections in the URL or the endpoint is nothing but a node. And then from left to right, you drill down the hierarchy. Uh, then you have a concept of resources. So resources here, for example, we have departments, IT, and employees. So uh, here, all of those are collections, but then if you have an employee API, which denotes a single resource, then it would be, so for instance, if we have a company before this, then that would be a single resource. And then later on, it can just drill down into different resources or collections based on your use case. Collections is a list of resources. So here in departments, obviously you'll have IT, sales, and the list would just be based on what your use case would be. And then, uh, so that's basically the concept of collections. Next, we have query parameters. So once you have optimally designed your endpoint, uh, you want to filter out your records, right? So in order to do that, HTTP provides query parameters that facilitate us to filter our records and make it intuitive and usable, right? So with all these concepts, you might be thinking, we have URI parameters which are kind of behaving as a filter, and then we are saying that we can use filters or the query parameters in order to get what we want. So the the idea of URI parameters is not to filter out any records, right? It should basically drive from the US postal address example that I gave you, wherein you don't really have an endpoint, but you want to establish hierarchy with the use of URI parameters, which will facilitate you to get to a proper hierarchy. And then query parameters should focus on giving you what you need based on a query. So the best uh, comparison of query parameters is the where clause in your SQL query, wherein you get the details that you need based on those queries. Uh, so I've already went through this, but just wanted to give you a flavor of the challenges that you would face while designing these APIs. So I have this example wherein I want to find out all the employees in IT who live in New York and are on a contract job with our firm. So there can be different possibilities here, right? Wherein I can have departments, IT, and then employees. So I can have everything in an endpoint. Uh, if you look at it, it is not very intuitive. You might be thinking, how can employees go to a location, and then the hierarchy just doesn't match. So there's an obvious confusion, and there's no the usability aspect is missing here. In the second one, you have a mix and match of URI parameters and query parameters. Obviously, the employees and location still doesn't fit very well here, and this wouldn't be usable in the long term. Then I have the last option wherein I have the proper hierarchy of departments, wherein the URL is taking me to IT department, and then I'm looking for employees in IT. And then after I get the employees, I'm filtering out based on the location and contract. So this is giving me a very good intuitive design. Obviously, it depends on the case by case basis when you would get into the real world. But then uh, this is some example that I wanted to give you so that you get a good understanding of the challenges that you would encounter in design. So that was the request part. Obviously, you can send a body to the APIs, and that can be put in the API specification as well. So another important factor in API design is responses. So when we are talking about interacting with so many different applications, it can be another API, it can be a web application, or any of those Industry 4.0 technologies that I talked about. So the feedback from the API itself is very important. So while designing these APIs, you need to think about all the different options or the status codes that HTTP provides. The popular ones that you have to remember is the 2x series, 4 and 5 series, right? So 200, the ones which range in 200s are the success messages. So based on the method that you use and the scenario that you have, you may want to pick the right status code. So this is basically a standard, and developers who are building and using APIs would know what these mean, and you guys can basically talk in the same language if you both have the information here. Also, along with statuses, you may want to send messages appropriately. So, for instance, if you are getting a 404 error, then it is a not found, which is you can specify the message in your domain as in what went wrong and stuff like that. So you can use that based on your use case. All right. So with that basic knowledge, let's go and cover the Design Center demo. So I'll be logging into MuleSoft Design Center. So I'm in the Design Center now. You'll have to create, if you don't have an account with your organization, you may want to create a trial account for 30 days. And you can use these features on the Anypoint platform. So the URL is anypoint.mulesoft.com, and you'll have to navigate to this left option here and select Design Center, and you can create a new project. So I have two files here. I've already built this. So wanted to demonstrate RAML and OS. So looking at these side by side, you would be able to uh, get a feel for what these technologies are, how powerful they are, and then how different they are. So as we speak, OS is the standard technology that is being widely adopted these days. And even MuleSoft has recently put in support for that, and you can uh, use that technology as well. Initially, when MuleSoft was built, it was primarily focusing on RAML, but then they've extended the API specification support to OS now. So let's get into RAML, right? So here, if you notice the first tag, so we are using RAML 1.0. The previous one was 1.0. So this basically is an annotation which says that we are using RAML. You can add a title base URI. So base URI is nothing but your the domain URI or your company's domain name that you prefer to use. So let me show you one thing. So uh, when I make changes here in my editor, you will notice that the documentation here is changing. So as you develop your uh, RAML specification here, your documentation will continuously adapt, and it will show you all the options here. And with that being said, let me get into the code itself and explain you what these mean. So here I'm talking about the department's URI, the same one which I used for as an example in my last slide. So we have departments API. I can have a get API, which will get me all the departments. Similarly, I have the URI parameter. Keep in mind that you have these curly braces, which are denoting these as a URI parameter, and then you have a get method for this too. Also, notice that each of these parameters or the code that you're writing is tab separated. So the tab basically gives the hierarchy of how you want to navigate through the code. And also, as you start typing, you will notice that you will get some suggestions from MuleSoft to edit this specification. So there is some IntelliSense here down. so that you can quickly add something which is applicable there, and then you can start using it. So overall, I built this API. I put some examples here, so that will basically uh, give me enough specifications to run these APIs. So let's focus on the employees API because I have these query parameters here. So I have the display name. I can define the type, min, max length, and some examples. The second one, I have the employment type, right? So employment type can be contract, full-time, part-time. So what I'm doing is I'm basically restricting or the data that can be passed into my API, so which ensures a proper contract and also helps in security. So once I build this API, I can go ahead and uh, review my API here. So here I have three APIs as I have designed here, and I can get into one of these, and then you can see that the description have been populated here. I can drill down into the get method. So if I drill down into the get method, I see the 200 status here, which I've put, and I see the sample message. So the design itself is resulting in a documentation here, which will be used throughout the life cycle of this API, right? So similarly, uh, it would be very intuitive if we look at the employees API because we have some restrictions there. So if you notice, we have query parameters, and then uh, it will tell you what each of these query parameters mean, and it will also mention the restrictions that we have put here, like uh, enum for the type, and we have a restriction of 2 characters here for the state code, and also you get the sample response here. So good stuff, right? So similarly, let me go over the OA specification here. Uh, you'll notice the semantics are different here, but then we are pretty much doing the same thing. Even the design that I have for the same endpoint results in a similar result here. The documentation is pretty similar, right? So important things to note here are its Open API specification. So here, instead of base URI, you have the servers tag where you put your URL, right? And then you have this paths uh, attribute where you can define your endpoints, and then the hierarchy just keeps going on. So this is primarily using JSON to identify the language hierarchy, right? So, so this will result in a very similar thing. It's just about going through it. It does have some more capabilities, and it is uh, more powerful than RAML. So you would be probably good if you end up using OAS instead of RAML at this point of time. Okay, so we talked about customer feedback, right? And that's pretty important in an API project. So let me go over that here quickly. So if you notice on the right-hand side, we have the mocking service. So you have to enable the mocking service here. And then soon after you enable that, MuleSoft will give you a mocking endpoint. You'll also notice that the base URI would have changed here. So let me get into one of these APIs. So let's get into departments. So for the department API, I have this URI, which has the department endpoint here. And so let's see what we have here. So we have code examples here, right? Uh, so you can use curl, HTTP, JSON, Python, whatever is your preferred language. We have a sample code here, so you can just pick this up and embed in your code. Let me try curl here. So I have curl installed already. I'll just put this command here. I'm executing it, and voila, we get the sample response that I have here in the example. So we have a prototype built already. A developer from other team can use this endpoint and start building their website or their applications right away because we have established this contract. So even before we build and be ready with our contract or the design or our build, we can already empower our developers to continue their work based on the contract. So that's all I had for this session. Uh, Thank you once again for your attention in this session. Uh, you can stay in touch with me. I have my LinkedIn ID here, which is linkedin.com in Ogireddy's. Thank you again.